China's effort to develop the J-15DT electronic warfare aircraft is part of its broader ambition to field a modern and capable carrier strike force, but the program's realities are shaped by technical compromises, legacy airframe limitations, and persistent concerns about reliability and long-term viability. The J-15DT is a specialized variant of the J-15, itself a heavily modified copy of the Soviet Su-33, which China obtained indirectly through a prototype acquired from Ukraine. This origin has long influenced the design, weight, and aerodynamic characteristics of the J-15 series. While the airframe has undergone extensive Chinese modifications, the core design is dated and was not originally intended for the full range of missions it is now being adapted to perform, including electronic warfare, which places substantial additional demands on aircraft systems. The J-15DT is designed to fulfill a role similar in purpose to that of dedicated electronic warfare aircraft used by other naval forces. It is configured to carry multiple electronic warfare pods and signal jamming systems, likely integrated with onboard mission systems that allow the aircraft to detect, track, and disrupt enemy radar and communications. These capabilities are critical for escorting strike packages into hostile territory, degrading the targeting capabilities of modern surface-to-air missile systems, and providing a protective shield for other aircraft operating in contested airspace. Unlike traditional J-15 variants launched from ski-jump carriers, the J-15DT is optimized for catapult-assisted takeoff. This makes it compatible with China's new electromagnetic catapult-equipped aircraft carrier, the Fujian. The catapult launch capability allows the aircraft to take off at full load, including heavy electronic warfare pods and additional fuel, which was not feasible with the older Stobar, short takeoff but arrested recovery carriers such as the Liaoning and Shandong. This alone marks a major shift in the aircraft's operational potential, as range and payload limitations have long plagued the earlier carrier fighters within China's Navy. However, despite the advancement that catapult compatibility brings, the J-15DT remains fundamentally limited by its underlying platform. The Su-33 was originally designed as a heavy air superiority fighter for short-duration sorties from Soviet carriers with limited operational requirements. It was not engineered for long-term multi-role operations, and the added weight of electronic warfare equipment further strains the airframe. Structural fatigue, landing stress, and aerodynamic performance are all areas where the aircraft is likely to underperform compared to purpose-built modern fighters. Power supply for electronic systems is another key limitation. Advanced electronic warfare operations require a significant amount of electrical power to run high-energy jamming equipment and sensors. The J-15DT reportedly relies on internal engine power to supply energy to these systems, as opposed to using independent power generation units such as ram air turbines. This design choice may limit the ability of the aircraft to operate all systems at full capacity simultaneously, especially during high-demand operations. It also places additional strain on the engines, which are already working under stressful conditions during carrier launches and landings. The J-15 series as a whole has experienced reliability issues, especially in its early years. Incidents involving loss of control, aborted landings, and system malfunctions have been documented over the past decade. While many of these may have been addressed through incremental upgrades and pilot training improvements, the fundamental issues of airframe wear, engine stress, and complex carrier operations remain. These are not easily solved problems and often take years of operational feedback and iterative design changes to fully address. China has made a transition away from the Russian Alabama 31F engine, which powered early J-15s, to the domestically developed WS-10 series. The WS-10 has seen numerous iterations and gradual improvements, but it remains under scrutiny for performance consistency and durability. Carrier operations are notoriously taxing on engines due to repeated high-thrust demands during launches, sudden power changes, exposure to saltwater environments, and arrested landings that require aggressive throttle inputs for go-around contingencies. These factors accelerate engine wear and highlight any deficiencies in engine design or production quality. Even with upgrades, China's engine technology in this category has not yet proven itself to be at the same level of reliability as mature Western counterparts. Another major challenge with the J-15DT is training and operational integration. Introducing a new aircraft variant, particularly one with advanced electronic warfare systems, requires a significant investment in specialized training for both aircrew and ground personnel. Pilots must be trained in the use of jamming systems, electromagnetic spectrum management, and coordinated operations with other aircraft and ships. Maintenance crews must learn to diagnose and repair unfamiliar avionics and sensor systems. There is no evidence to suggest that China has decades of institutional experience in deploying carrier-based electronic warfare aircraft, so these capabilities will take time to mature through trial, exercises, and eventual real-world deployments. Furthermore, the J-15DT exists in a transitional phase of China's naval aviation development. While it represents a needed capability in the electronic warfare domain, it is also likely a stopgap solution. Its design is based on an aging platform, its performance is constrained by structural and power limitations, and its effectiveness in real-world conflict scenarios remains entirely untested. It fills a role that China lacked, but it does not redefine naval warfare or establish technological superiority. Rather, it illustrates the stage China is currently in, expanding rapidly in quantity and capability, but still catching up in terms of maturity, integration, and platform efficiency. The long-term trajectory for China's carrier air wing likely includes more advanced aircraft designed from the outset for catapult launches, electronic warfare, and stealth operations. The J-15DT, like the broader J-15 family, is a product of reverse engineering and adaptation rather than original innovation. Its existence reflects an urgent need to develop domestic alternatives to foreign technology and a desire to close capability gaps, but it also underscores the limitations of building advanced systems on outdated foundations. In operational terms, the J-15DT will likely perform escort jamming roles, provide electronic suppression during strike operations, and support fleet defense by degrading the effectiveness of incoming threats. However, its overall mission success will depend heavily on the reliability of its systems, the competence of its crews, and the operational stability of its carrier platforms. These are all still in a development phase for China's Navy, and while progress is being made, it is measured and gradual, not revolutionary. The J-15DT is a step forward, but it is also a clear reflection of the compromises and constraints that continue to define China's military aviation efforts.